Hello, everyone. Good morning. Does this work? Yeah, you can hear me well. First of all, I have to say that I truly appreciate the way my surname is pronounced here. Okay, it's very rare to hear it pronounced this well. I'm, as I said before, very glad to be here at this conference for many different reasons. First of all, my links with Switzerland are tighter and tighter. My collaborator, one of my most important collaborators from MIT, from the Sloan School, where I'm doing most of my research, is Swiss, so I happen to be here every now and then. And also, it's great to be at a conference that is treating data science and machine learning so seriously, the way it deserves to be treated, really. So I wanted to speak to you today a bit about context awareness, because I think it's an emerging notion that starts to matter kind of more and more in the context of data science and machine learning, but also in the context of IoT, in the context of human-machine interfaces that we have more and more of. So first of all, I would kind of start with saying a bit about where AI is today to give you kind of a, let's say, bird's eye view on artificial intelligence as it stands, having this division kind of in my head. Because on one hand, I'm working at Kosminski University in Poland. We have established AI and business program there, trying to teach students from Central and Eastern Europe about how to link artificial intelligence with business, with enterprise, and so on. On the other, I spend most of my time in Boston, and I see how perspectives, let's say, of developing artificial intelligence are different in, let's say, these transatlantic conditions, how much that differs in the US, how much that differs in Europe. So obviously this does not have to be the truth, but it's definitely my way of looking at it. So if I was to respond to the question on where AI is today, I would say that it's definitely here. It's not in the future. We're not talking about artificial intelligence, about AI as something to come, or as something that is supposed to be ahead of us, but we're talking about it as something that is already here and already implemented in various disciplines. So this slide, as much as it's perhaps not super visible, shows you really the opulence of solutions in terms of data science, machine learning, machine intelligence 3.0 for enterprises, organizations, and also individual users, right? So what you can see here is that we have a lot of that already developed and ready to use, and I think that's very important. We can handle different types of data quite effectively already, visual, audio, but also sensor data, more and more present. We have different solutions for enterprises and their respective functions. We have different industries that are very effectively penetrated by artificial intelligence at this point. So we speak about agri-tech, not agriculture anymore. We speak about legal tech. We don't speak about the legal services. We speak about logistics, still, but I guess we could call it logitech in the future. And we can also say about something meaningful about fintech, obviously, and about retail tech. All of these disciplines, industries are penetrated by artificial intelligence, and the tools for them are already there. But the most important aspect of this slide that I quite often show to my students, I've discovered it recently, and I wanted to share it also with the student community at MIT, and we talked about how AI becomes simple. And I think that's another key point here, right? The key point is that it's no longer so important to learn artificial intelligence, to learn data science, and to really focus your career on acquiring skills that are really hard and they're not easily accessible. But actually, you can start using data scientific tools and machine learning tools even without the capacity of coding. And I think that's a big revolution. That means that AI really becomes an opulent, abundant tool for everyone. And it goes together with the initiative that was recently announced at MIT to build a college that would focus on raising students who are, for instance, both a biologist, a pharmacist, a chemist, a historian, or let's say a finance person, a finance analyst, and at the same time a data scientist, right? So you think about AI, about data science as a tool for everyone in their respective professions. And I think It's a very major change that is currently happening. Also, on another hand, for instance, my students, very often when they start their adventure with AI, I tell them, you can, for instance, build your first bot without coding. You don't need coding for that. You don't need these skills. You can actually make it work. You can also design your first data scientific experiment without coding. You can just use drag and drop tools. So simplification of artificial intelligence and data science, accessibility, allows it also to scale to different professions, to different dimensions, and different industries. And I think it's a very important trend to kind of follow, even though we, let's say, as data scientists, want to dwell deeper into the topics, want to dwell deeper into the methods, the others may want to use them too without that level of access. Where is AI mainly used? I would say, well, currently it's mainly used for solving technological problems. So AI is mainly deployed in the fields that are related to, let's say, the work of technology or the fact that technology fails and so on. But we also see it being scaled in various other domains. I see it particularly in the US, how the situation has changed over the past 2 or 3 years, right? Whereas 3 years ago, people were speaking mostly about how AI is going to be deployed somewhere soon. Currently, they're just talking about how it works, whether it works or not, and how to improve it. So we see it being deployed in marketing. We see it being deployed in finance and accounting already quite extensively, also in customer service. And that's my field, specifically because our team works in human-machine interaction and works mainly with bots and natural language processing. So clearly, customer care is sort of our field here. And I have to say that obviously this is not the only thing that makes AI thrive. In a way, we're currently in a very peculiar situation, and I think data scientists, people who have been working in AI for a while, can be a bit surprised by the buzz that it currently gets, right? The buzz that is generated around it. And it's true to say that artificial intelligence has become the key topic for everyone, for politicians, for the society, in many different contexts. So on one hand, we see it being deployed in business quite extensively. On the other hand, we see it being a topic that it becomes very relevant, for instance, on the European agenda. We can also talk about it in the context of geopolitics. We have the Chinese, let's say, AI, and we have the American AI. That's what people talk about a lot. And if you follow what's been going on in the media, for instance, MIT Tech Review has been releasing a very interesting series on articles about, what is the Chinese, let's say, pathway towards artificial intelligence and what is the US pathway towards artificial intelligence. A year ago, the situation was completely different from what it is today. A year ago, we were mainly speaking about, for instance, citizen scoring system as something that is a point of concern, let's say, for Western civilization that uses similar or the same data scientific tools for different purposes. But today, a week ago, the Chinese government actually announced that it's going to reconsider the Chinese citizen scoring system as a project that needs to be revised because it's potentially threatening, it's potentially something that could actually damage many things instead of building up. So that's definitely something that is quite relevant to follow. And obviously, artificial intelligence became also a key notion in the context of the future of work. And that's something that is very obvious. And many people address the issues of the future of automation. Again, if I was to speak here a year ago at the 5th edition of your conference, I would probably say, yes, we're talking a lot about automation, how many jobs, professions are going to be automated, how machine learning or AI can effectively take over jobs. Today, I'm talking more about cobotization. I'm talking about creating spaces of good synergies between humans and technology. And that's not a trend that's been out there a while ago. A while ago, we were talking about, how much can be implemented in order to somehow replace humans. Today, we're caring more about creating safe, good environments for humans to thrive, together with technologies, to create assistive technologies so that they can be enhanced in their mental or physical capacities. And this trend towards cobotization, collaboration with robots, I think it's quite a relevant one. Although, on the other hand, this book the AI gig economy, I don't know if you heard about it, but it's, I think, quite brilliant, talks about how you can also deploy and develop AI systems that are going to manage precarious work of humans. And I think that's another point of looking at it that is also quite relevant to raise. So generally, we definitely are in a very important moment for artificial intelligence and for data science, at quite a decisive moment in many different ways. And that's something I'm also going to come back later on. But I wanted to speak about context awareness today, and I will use my own work, and I will use some of the examples of the projects we develop to tackle this very important issue. So as I told you before, we're working in the field of biotics and artificial agents. We're doing various work that is related to researching the flow of interaction between a human and an AI system that speaks, let's say, very broadly. And in this field, there's a lot happening with the context, right? So there have been quite a few impressive developments in biotics that I find very relevant. It's hard not to mention Alexa. There are 60 million Alexas in the United States. I'm Polish. There are almost 40 million Polish people, still less than Alexas in the United States. And I find it quite striking. This is a fairly simple system, you can say. Okay, it processes the language, has a fairly good speech synthesis, but it's still used mainly for purchasing decisions, buying things on Amazon. And obviously, it makes things very easy that way, because, for instance, when I'm in Boston, my shopping usually looks like that I just say, okay, I want this, that, and that. Alexa confirms that on the next day, or even on the same day, it's there. So that makes things easier. It's also been deployed in other domains. Let's say it can connect well with sensors, with the IoT in the house, regulate the temperature in your house. It can be used to turn on the coffee machine when you wake up in the morning, when it knows that you actually woke up in the morning, and that's a bit of context on its own. But still, it's not the most impressive system, right? There's yet more to be seen. And we can observe Amazon. And Amazon says, for instance, in the future, it's also going to be a tool for your financial transactions. We want you to use Alexa to transfer money, which is yet another added functionality. We want to use it for therapeutic purposes, for various people with, for instance, speech impairments, so that they can practice. We want to use it in many other domains. So we haven't seen much of this development yet, but we know that the plans are quite broad. Another very important thing that's been happening in the field of biotics, where you can see bits and pieces of context here and there, is the IBM project Debater. I was actually there in San Francisco this year in February to observe the battle between Project Debater and a human. They had to talk about the future of education, higher education, and the topic was, should education be paid or should it be free? And actually, Debater was on the free side, and Human was on the paid side, so that was kind of interesting. I find it striking. So the professional debater, on one hand, was a person who was very experienced in debating other humans. On the other hand, you had an AI system that had crowdsourced knowledge about the field. By crowdsourced, I mean gathered, from various media outlets, really well processed and so on, but also directly connected and collected, right? So there were humans who would actually write their opinions, and that was assembled by the system in a broad picture of why education should be free. And I don't know if you guess what the outcome of that debate was. Well, it was very interesting because we had to vote there, and many people said, okay, Human was much more persuasive, but on the other hand, if I was to answer a question, who told me more about the topic, I would say that Project Debater did, and not the human. So AI had more knowledge, but Human was more persuasive. And I feel like many people treat it as a battle. Who wins is the major question. But on the other hand, we can look at it from the perspective of commoditization. And we can say, okay, Human was much more persuasive, but AI collected and brought more real-time knowledge based on solid data. And that's a very good example of collaboration to generate new knowledge. Also, the field per se, when you're a data scientist, you're like, oh, wow, that's very interesting to research. What is the database, the knowledge base of that system? This system collects information about major topics for the environment, for us, and so on, about climate change, about education, about vaccination, topics that are very often controversial. And what is there is an input from many diverse people, many diverse communities, that is being processed. And the interesting part is that if your opinion is very unique, it's going to be explicitly quoted by the system. But if it's a part of a broader, let's say, discourse, and it belongs to, let's say, a set of opinions that were already mentioned, it's just going to put some weight on that general argument. And you can, through that, research, for instance, how people feel about certain topics. You can research, can use sentiment analysis to see, okay, this topic is shaped like that, and also these communities express this kind of knowledge about it. You can research deeper. So it's a huge, vast space of crowdsourced wisdom or knowledge that can be explored in many different ways. And I find it very interesting in terms of application of natural language processing. There is more. These systems don't only, let's say, handle individual knowledge. They're not also only interfaces to interact with individual users. In terms of Alexa, it can also have very broad industrial implications. So you can talk about it as a tool for logistics, for instance, where it's going to inform you what is, for instance, in the stock right now. What are the needs? What else do we need to order? What else is out there? What hasn't worked? And so on. And I find it very, very interesting how the same devices and interfaces can be used for individual users and at the same time can be quite successfully applied in business, in smart home applications, and so on. So if we are talking about context awareness of these systems and systems that were before that, we can say, okay, context awareness has been out there for quite a while. What do we mean by that? Very often, we mean not necessarily very robust things, right? When humans think about context, so the context of my being here, talking to you, is very, very broad. How did it happen? Why are we all here? What's the purpose of this gathering? And so on. That would be kind of hard to compute, to explain, and to represent algorithmically. It's quite a big monolith, I would say, to handle. But on the other hand, so far in natural language processing and machine learning, when we were talking about context, we were talking about fairly simple features, I would say. We wanted to express that a system that has context awareness can adapt well to its environment. But on the other hand, by adaptation, we meant fairly basic things, like location, like time, for instance. So far, when you look at it, context awareness in various AI interfaces and systems was realized through the system knowing where it is, what time it is, what, in a very basic way, the activity is being currently performed, or, for instance, about the time zone, information about, the location, geographically speaking, so more broadly compared with other spaces and so on. And that doesn't seem like a very ambitious thing, although these types of contextual information obviously are very relevant. Then another thing appeared, another very interesting division, and that was how do we display the context? How do we really conceive the context? And you can here speak about at least two ways. One is explicit, the other one is implicit. One is gathering information when the application is in use, just constantly. The other is to turn it on in particular moments to have more contextual, relevant input. And that's already a very interesting, I would say, division. When do we want the context to be conceived somehow? How do we want to use the data? When do we want to retrieve certain data? Is it contextual data for us or not at all? And I think it's very important to have that foundation. And obviously, this foundation has been building up for a new type of context that we are already seeing today. So when we speak about context awareness today, we can say, well, we've moved a long way. Let's look at two examples. One is Google Duplex. I'm quite sure many of you, at least those who are working with natural language processing, have been quite shocked to watch it for the first time. It's a system that has been trained for 6 years to talk about two topics: how to book a table in a restaurant, how to book a haircut appointment. Well, these doesn't seem like, a very ambitious goal, but nonetheless, the way these functions of booking a haircut or booking a table at a restaurant are realized is quite surprising. Google has devoted a lot of time, all their, let's say, endeavors so far in natural language processing, in speech recognition, in machine learning, were connected together to build a system that can really speak to you. And that's a lot. By really speaking to you, I mean a system that can paraphrase the way you said something in order to say it in a different way, but retain the same meaning. A system that can also understand you when your speech is somehow broken. For instance, you didn't finish a sentence, and still it knows what you probably wanted to say. Yet another way of looking at it is that, for instance, your accent is different. And different accent, heavy accent, used to be a very big problem in botix, and actually it was really embarrassing in many ways how these systems would not understand what you wanted to say. Well, with this system, it's no longer a problem, right? It usually knows what you want to say. And it's because of the fact that its context awareness is so highly developed. It probably this conversation should go this way, and therefore I know what to answer to you, even if you don't say explicitly what you were supposed to say. And I think that's a lot. Another very interesting instance of context awareness is obviously this highly controversial case of GPT-2. So some of you might have heard about it, a system that was developed by OpenAI, a company that used to be owned by Elon Musk. Then he withdrew, at the best moment, really. He withdrew, and then it turned out that they just actually produced a very, very robust text generator. And this text generator can essentially finish any sentence that a human began. It's obviously, again, a machine learning, deep learning system that has been trained for several years to generate sentences that sound really true, or at least probable. And, well, the interesting thing is that if you say a sentence, and there was a very interesting example, somebody said a sentence about, how there are unicorns, and they live in some Peruvian village, and they're happy there, and that was essentially the sentence, and GPT-2 would reply, yes, they're very happy. They were discovered 60 years ago, but Professor Smith, who also visited that village and ever since stayed with them, and he's still writing on them, and they're so happy together. And it was like a very good story. It was completely fictional, but it was a very sound story with a very good narration. And the system, interestingly enough, can do the same for scientific articles. It can just essentially finish a scientific article, which will be completely fictitious. It will not be a real article, but it will sound like one. And because of the fact that it can generate narrations and stories, let's say in a very good line of argumentation and very well encapsulated so well, it was called a deepfake for text. 2 days after it got released, the company decided to withdraw it. It's currently not available on the market because it's too threatening. It seems like a very powerful tool, but it's not going to be used by the industry because of the issues of ethics, right? And potential dangers for, let's say, democracy, spreading post-truth, some sort of lies, and so on. And it's the first situation that I've been observing in my career in data science, where a company actually decides to withdraw something that could bring potentially huge revenues because of the fact that it can be a highly threatening context-aware system. So that's very, very interesting. So this is what we have today. We have it, well, some of them we don't, because we don't get to see it because they've been withdrawn as projects. But nonetheless, this type of context awareness is already there. And yet we have more to come. There have been some very interesting announcements about what we can really retrieve from, let's say, human-machine interaction on the level of context, even though, let's say, some of it still becomes very cryptic. So I don't know if you've heard about this project. It's called TomNet. So I studied analytical philosophy, logic, semiotics. At that time, I started also writing my first bots. And in philosophy, we had a lecture on philosophy of mind. And there was a very important notion there that was supposed to be extremely theoretical, but then very valid, and that was theory of mind, or theory of other mind. That's how it was called. Theory of other mind was assuming that when I speak to any of you, I usually have a certain notion of the fact that you have intentions, that you have ideas, and also emotional and affective states that you go through while we're talking. And this allows us even to have a communication. So it's very relevant. It's not about the content or what you said explicitly, it's about what happened in your mind while you were speaking what you were speaking. And we thought all that it's a very interesting concept, but not to be proven. And then comes DeepMind with its idea to actually say, okay, we can create a network that's going to have a theory of other mind. And I find it very, very interesting. DeepMind obviously is the same company that came up with AlphaGo and AlphaGo Zero, very famous cases of AI deep learning systems that competed and won in the game of Go, effectively changed the paradigm of the game of Go. And now they're saying we're going to build a system that is not going to have any type of consciousness on its own, but it's going to realize that you're going through mental conscious states, and unconscious too, probably, while you're talking to it. And I find it a really next level type of context awareness. So here you can see how they've built it up. The paper is also to be retrieved, but as I said, it's a bit cryptic in the sense that they've announced it, they released the paper, but the system is not yet there. So we'll see what's going to become of it, but how they've put it. We formulated a meta-learning task. We construct an observer who in each episode gets access to a set of behavioral traces of a new agent. Not a human yet at this point. The observer's goal is to make predictions of the agent's future behavior. Over the course of training, the observer should get better at rapidly forming predictions about how this other agent is going to behave over time. And I find it very, very interesting. It's actually based on a very complex approach. It's not any type of brute force solution, where we're saying, okay, we have to actually generate quite a few observers here. One will acquire general theory of mind, and it's going to learn about population and its probable predictable, let's say, behaviors. And the other one is going to learn about a specific agent, and then these two will compare their results to actually come at a final goal of understanding the intention of, let's say, human speaker, because these are the most refined ones, in a conversation. So this is the future, I think, of context awareness that is highly interesting. For those more geeky, it's also, as I said, the paper is to be retrieved. It can be retrieved online. Happy to provide references later. It's based on partially observable Markov decision models, so actually an architecture that we've known for quite a while. Now, I wanted to say a bit about our research and how it's located also in the field of context awareness. So as I told you, we're building various types of bots. We're trying to research them and understand how they behave. We are not building a TomNet yet, but actually a goal of creating something TomNet-like is also in our heads. So I'm working mainly at the Center for Collective Intelligence at MIT that has been dealing with processing different types of online data. Currently, we've changed, and we've decided to look more at sensor data, because these seems to be like a very interesting space to penetrate, where you can actually get the most of context. And we've been building various models of online behavior of people, interactions of people online, and so on. And also, again, recently when I joined the team, we decided, okay, it's not only human-human interaction online that matters, but it's also human-machine interaction that matters too. So we've decided to create quite a few samples of bots, machine learning-based bots, nothing really simplistic in a sense that we were not interested in state-of-the-art bots that are just very basic in the sense that they just give you a reply that is by no means contextual. So we've decided to create this bot, and we've deployed it at my other university in Poland. The bot is called Ola, which is Alexandra in Polish. just to make it harder for everyone. So this bot actually worked at the university for a year. It had very little knowledge of the university life, and yet it was supposed to work in the dean's office and provide information about, the fees at the university, the courses, the faculty, and so on. So it knew nothing at the beginning, and then it was supposed to connect with the students and collect knowledge from them. So my students taught it many different things, many things about life, not only about the university, but also sometimes curse words, for instance, which I then had to diligently delete. They would pose many different offers to the system. Sometimes they were a bit mean to it in the sense that they would say, oh, you have no childhood, or you don't have any memory of anything that ever existed because you're just a bot. Just admit it that you had no mother, or something like that. So it shows, interaction between humans and machines is very tricky. Humans tend to be quite cruel sometimes. But nonetheless, I would say the overall picture was that apart from the curse words and all those nasty comments, the system really found out a lot about the university from our students. Then it was supplemented by another knowledge engine that we prepared for it, and we thought it was ready for an experiment. What was the experiment? The experiment was that we set up two versions of Ola. One version of Ola was quite capable of multi-level interaction with the human. So it had eyes with a gaze. It had an eye tracker installed, so it could reciprocate your gaze and look back at you when you were looking at it. It could also use a voice with fairly good speech synthesis, I have to say, although there was a certain shallowness in that voice, and that's relevant. I will come back to it. And it could actually it had an avatar, so it could actually speak to you, let's say, from the screen as a person. There was another version of it that was just text-based and looked like a messenger interaction. Essentially, there was nothing very special about it. And they both, for the purpose of the experiment, said the same things, because the students, each group consisted of 16 students, and each group had to fulfill a certain task with the chatbot, and they had to have an interaction with it, and we controlled it severely so that we could actually have good results in the experiment. The groups and the talks with the bot had to be comparable. So one group was talking with the text bot, the other one was talking with the multi-channel bot, and we were interested in a specific effect that everyone who researches human-machine interaction knows quite well, and that's the uncanny valley. So if you don't know what the uncanny valley is, this is it. It's just blunt to see. If there are robots, and these are robots on the screen, that look too human-like, for various reasons that are not essentially clear, we are afraid of them. We know that there is a certain sensation of eeriness when you're interacting with something that is hard to classify for you. You don't know what it is, and you're not going to react well when you cannot decide whether this thing is dead or alive, for instance. And that's probably a very old biological response to something that, well, could be ill, for instance, could be dying, and therefore should not be moved. That's one of the possibilities. So we definitely have a lot in us that regulates the interactions with these systems. Let me just, because I wanted to show you, do I have it? Oh, somehow one slide is gone, but then I will just make a brief reference to it. We've recently wrote a paper about this uncanny valley, happy to share it later, where we are showing various traces, how it can be reconstructed. So there are biological responses that are saying the uncanny valley is there because we were geared up with it to just run away from things that are possibly dead, scary, whatever. There is another, obviously, set of explanations that tells us, okay, it's more of a not biological, but religious register, where we feel that humans should not create something like that, right? Other humans, human-like characters. So what we decided to do is we rolled out this experiment where we were using two types of, let's say, evaluation of human-machine interaction. One was physiology, where we would just hook people to different electrodes. That's the way, to roll. When you just want an answer, and you feel that what people say doesn't necessarily have to match the reality, you just hook some electrodes here and there, and then you at least get certain idea about the affect emotion that is happening while the interaction is also happening. So we decided to hook these electrodes, and during the interaction, we just registered all the affective states of humans that were going through it. It was very hard on its own. In terms of data scientific task, it's actually very hard to work with human physiology. First of all, it's very hard to interpret because there are also external artifacts that can really influence it. There's another problem that these signals per se are hard to interpret because they're very ambiguous, right? They can mean positive, negative emotions. You very often know just the intensity of it, not the vector. But nonetheless, we really dug hard, and we decided to look at that data. So what we saw is that our text chatbot was not really quite arousing or engaging for humans, right? The simple text chatbot was just very basic. People had very low reactions that we registered to it. They just had the interaction, then went home. The other one, with avatar and voice, was much more engaging to them. And they were really quite invested, we could say, in the interaction. And that was confirmed across all the channels that we had. So here you can see, for instance, facial myography. You put electrodes here and here. I know it sounds creepy, but that's the way it works. And then you can see whether people are frowning or smiling, for instance. So here, that was confirmed. Here is another very important physiological channel, and that's the heart rate. And again, the same result is confirmed. But when you compare that with questionnaires that we also used in this study, and when you really dig deeper in the physiological channel, you see one important thing. Actually, these people hated the multi-channel bot. The people who were so engaged, that reaction was stress. They were not willing to interact with it. They evaluated it as stupid. They evaluated it as, let's say, also untrustworthy, and so on and so forth. Even though both of the bots were saying the same things, one of them was evaluated as trustworthy and okay, and that was the text bot, whereas the other one was evaluated as someone stupid, unworthy of interacting, and also someone I don't want to work with ever. So that's interesting, right? So that's interesting, and that tells us also a lot about how future channels of future human-machine interaction should be implemented, how they should be designed too, because perhaps there is a way of omitting this effect, but you have to be very careful, because you can build a system that is going to be human-like, but if you put too much human features in it, it's going to be a spoiled effect. And one of interesting examples here is also when Amazon was trying to think about how Alexa would crawl around the house and walk, and for instance, come closer to you when you are speaking to it. Right? I mean, that sounds like a nice feature, but then in your own house, when it's crawling around on the floor, you actually have that eeriness in you. Why is it following me, right? Why is it going after me? So I think it's very relevant to have that in mind. Obviously, you would gain some context for the interaction. It's good when someone has certain traits or like gestures. Yes, I'm attentive, I'm listening to you, but when it's a robot doing it, it's actually quite wrong. So another thing that I wanted to show you was what we did with the logs. We had, as you probably can imagine, many, many logs from these interactions that people had with both of our systems, with Ola 1 and Ola 2. And we said, OK, we have to do something with that. So we've used a system called Tribe Finder that was actually established by Peter Gloor at MIT. It's a deep learning methodology for text classification. It relies partially on sentiment analysis. You can take logs from any type of interaction that you want. Any type of content really is good enough. And then using that content, if the volume is right, you can classify the text, and you can see, where this particular person or this particular database fits in terms of broader categories that we've implemented. Again, happy to release the paper. So when you have enough text about someone, let's say their Facebook account or their Twitter account, you can say whether that person likes to do sports, what kind of ideology this person represents. In terms of personality, if it's more of a journalist or a politician, that's quite interesting combination. I know it's, at the European Parliament, I recently mentioned that we have that that system, they didn't like that division, that when you have honest speech, you're a journalist. When you're like a propaganda talk or like influencing others, it's more of a politician, but that's how we've divided it. Then we can also classify someone according to alternative reality. Are they more of a nerd or a tree hugger or whomever? And in terms of lifestyle. So what we've decided to see is not, how that gets to be displayed in humans, although that can be done. And by the way, it can also be done for organizations. Here you can look at the data that they themselves generate, but also data that is generated about them, for instance, with a hashtag. And then you can see general sentiment around them, right? It's how they are perceived, what are their values, and so on. I think a very interesting tool for business analytics and business intelligence. But we've decided to see who is our bot, especially that the bot was mainly fed by people, and the length of the interaction with humans would actually determine who the bot was. So it was true indeed that the bot had certain personality. It was more of a journalist than a politician. It was more of a, let's say, a person that preferred being in nature than a person who likes to sit in front of the computer, and so on and so on. But what was more interesting, and what was the relevant discovery in this research, was that the bot would always change its mind. The bot was a Republican when the person it was speaking to was a Republican, was a Democrat when the person was a Democrat. Obviously, there is a reason for that. Bots have a very short memory. They very poorly manage dialogues. Very often, they don't make references to the beginning, and often, because of that, they just agree with what you said in the line before. So that's how it is today, and many of these systems do it, even the most refined and context-aware ones. But that's obviously a problem, right? That's obviously a problem because if we really think about bots as human-machine interface of the future, where applications or apps are no longer popular among younger generation, they prefer to talk to Alexa, then that's something that matters, right? We want systems that are going to be somehow representative, let's say, of the views of organizations that they're supposed to represent. So that's, I think, very relevant to think about. We've actually had very lengthy discussions about, what it means to trust a bot in the context of both of our research fields, right? So do you trust something that is too human-like? No, you don't. So you have to really manage well the degree of anthropomorphization. You have to trust that the system has an expertise in the field, right? That it knows what it's saying, that it knows about the field, that it was well-trained to do these types of things or reply to your questions and so on. But you also need the system to be transparent. So if a bot calls you, you should know that it's a bot without guessing. It should just be explicitly said. It should also have certain degree of integrity, which means it should be able to represent values and missions in a way that is sound, even though it is supposed to follow the user, and you should be able to switch it off. And here, the example again of Alexa that gets to be turned on every now and then randomly in the house just to record your speech, to refine the speech recognition mechanisms is not really that good, right? Because it shows you that a system can be randomly turned off and on, and you don't know about it, and it's in a very intimate situation of your own house. So we've done that, and our next steps are to really make use of it. So we've discovered things that are not working well, and now we are thinking about developing a system that is going to be better. So since we know already how to collect physiological signal and how to read it, I think, quite well in particular context of interactions with these channels that we have used, we can try and loop it back, for instance. So we could package that information about how the user feels, for instance, to shut the bot down. If the user is not happy to talk now, if the volume of this speech indicates that, then perhaps this conversation should end. That's a very interesting, I would say, solution that is worth considering. And we could also use the system that I've just shown you, the TomNet and its architecture, or we could use any other type of AI observer architecture to essentially track, how particular interaction went in terms of physiological signal and how general situations go. So the general aspect is already kind of diagnosed. The particular is something that we still need to do in the future. So it also feels like we could do something around the issues of, let's say, soundness of interaction, where you can have a system that is going to adapt to the intentions of the user, but would still retain, especially if it's a bot that is supposed to represent something, certain interests, certain values, would still retain them throughout the interaction. That's something that we're trying to do now. And that obviously brings me to my last piece. I know that you have a track on ethics here, and I find it very relevant that we discuss these matters, because throughout our research, we've discovered how relevant that is to address it, right? Within data scientific community, we need rules, definitely. We need certain procedures to build systems that are going to be safe for the user, and at the same time will generate a lot of added value. And that's a very tricky part now, right? Every type of system, as we know, can be biased. We've noticed how our bot was being biased, for instance, throughout its history of interactions with my students, how it became, let's say, a fairly violent person because of the fact that it was using a lot of hate speech that was provided to it. And that can happen to any other system. So we need effective mechanisms of working with bias, not only after it happens, but before it happens. So I know that some big companies are already working with that, and I'm very appreciative of that, that we're trying to really think seriously about the bias that's been there for a while, but many people said like, oh, well, you know, I mean, that's just a part of reality. It's not and doesn't have to be. And the final point is obviously explainability. For every, as you know well, complex AI system, for every multi-layer neural network, we have major issues with explainability. Perhaps they're lesser when it comes to networks that process images. Here we can see a big progress in terms of explainability, but for those networks that are processing textual data, numerical data, which is our case, this explainability is still very low. So what we're hoping for is that when we create these observers in our bots, we can actually add some to the explainability. It's not going to be a full solution, but we're going to be closer to understanding how the interaction flow is actually going and why certain responses are generated. So here I would like to stop. Thank you very much for listening. And if we have any more questions, then I'm happy to take them. Thank you.